All right, and in Math 60, we're talking about today decimals and fractions. So, where do decimals fit in the set of numbers? So you have actually three different kinds of decimals. You have repeating decimals. All rational numbers, all repeating decimals, could be written as fractions. So we call these rational. And we were talking about the pattern earlier in class. We were talking about how 1/9 is equal to 0.1 repeating. What about 0.72? And this will be in your textbook as well. Is going to be 72 99ths, okay? There's a whole entire video on Khan Academy where he talks about why that is. That would be a little bit more than I can get into right now on here. But essentially, if you make this, how do you make a fraction into a decimal, first of all? Does anyone know? Divide. Because that's all this fraction bar means. If you see a fraction bar or a divide sign, they're the exact same thing. You see how you have A over B, which makes it rational because you can write it as a ratio. Then we have terminating decimals. Terminating decimals, what do terminating decimals do? They end because the terminator ends your life. So the terminating decimal ends. What is this one equal to? Can you make it into a fraction? How do you actually take this and make it equivalent to 1/2? We know it's 1/2, but how do you make it so? How do you take any decimal and make it into a fraction? Does anyone know? Yes? So you actually have to think about the place value. When we read this number, this is 25 hundredths. 25 hundredths, which reduces down to 1/4. So when we make a decimal into a fraction, we use the place value. When we make a fraction into a decimal, we divide, because the fraction bar just means divide. Now, if you have non-repeating and non-terminating decimals, one example is pi. All non-repeating and non-terminating are called irrational. So things like pi, which is approximately 3.141592654. Oops, 2654. I actually remember this because back in 2015, they said it was an epic pi day. March 14th, 2015 at 9:26 a.m. and 54 seconds. And that 4 is actually rounded. But if you press pi on your calculator, a lot of people use 3.14. That's not really accurate. That's an approximation. That's why we use the wavy equal sign for approximate. If you think about something like the square root of 25 is equal to 5, that would actually not be irrational. So that's over here. That's confusing. Why did I write it right there? But the square root of 26 is not a perfect square, so it's approximately, 5.1. If we use our calculator, we can see that anytime you take the square root of a non-perfect square, you're going to get, so the second square root, oops, that's not how I do it, second square root of 26. Oh, I was close. See, I rounded it off. But these digits, even though you're going to repeat digits, they're not going to have a pattern of repetition where you can use the bar. The bar tells me that specific digit is repeating until infinity. Okay? There is a part in your online textbook about this too. So use the textbook as a reference. Meaning that if you come across something that's confusing, of course, you can ask me. But you might also just look in the book, too, because it might have a video and it might also help explain a little bit. It doesn't really go into much details about why the 9s are happening. But and then, by the way, this one, we reduced it, right? What did it reduce down to? Do you remember? To 8/11ths. Does everybody know how I was able to reduce that to 8/11ths? What number goes into both? 9. Okay, so any other questions? This is not irrational. This is rational right here. Because you can write it as 5/1. There, it's a ratio. Okay. Let's stop the video.